When we usually look at making aquaculture more efficient, we think about genetics, or maybe automation, better hardware.
Right, new machines, that sort of thing.
But the stack of papers we're looking at today on tiger grouper farming, it points to a purely microbial solution.
It's such a fascinating pivot.
It turns out the key to hitting some major UN goals isn't a new machine at all. It's all about how you manage the water.
Yeah, we're looking at this document. It analyzes findings from sustainable aquaculture journals, and it draws this direct line from a single fish tank to huge global targets.
Things like zero hunger and responsible consumption.
Exactly. It's pretty amazing.
So we're talking about something called Biofloc technology. And the mission for this deep dive is to really unpack how this system works for the tiger grouper and, why it's such a game changer.
Well, the thing that stands out immediately is that Biofloc isn't just about filtering water. It's about treating the water as a living reactor.
Okay, let's get into the mechanics of that, because Biofloc sounds a little, bit like a sci-fi blob.
It's actually a really clever biological hack.
So in a normal fish tank, fish waste creates nitrogen,
Right.
which is toxic.
And usually you just flush that water out, lots of it.
But Biofloc completely flips that script. It manipulates the carbon to nitrogen ratio.
And this is the crucial technical bit. The bacteria in the tank, they need carbon to process all that nitrogen. So what the farmers do is add an external carbon source.
And it can be something as simple as molasses, which I just love.
It's that simple. You add the molasses, and these heterotrophic bacteria just go into overdrive.
They start consuming the toxic nitrogen, and then they clump together into these protein-rich flocks.
And that's where the magic really becomes practical. Those flocks, they're not just sludge.
They're food.
They're nutritious food. The tiger grouper actually grazes on them throughout the day.
It's the ultimate recycling loop. You're turning the fish's own waste, with a little help from bacteria, back into a protein snack.
And the data shows the fish thrive on it. The physiological impact is huge.
So what are we talking about here?
We're talking about significantly higher survival rates, mainly because the water quality is so stable. You just don't get those deadly ammonia spikes.
And that stability, that reliability, that has to be the bridge to that first big goal we mentioned. SDG 2, zero hunger.
Precisely. If you stabilize the survival rate, you stabilize the food supply. It means you're producing high-quality animal protein with a much, much lower risk of crop failure.
That's the definition of food security right there.
It is.
But the higher survival rate is really a byproduct of a much cleaner system overall, which I guess brings us to the environmental side of things.
Yes, and this is where it really clicks for SDG 12, responsible consumption.
The resource efficiency.
This is what really stuck with me from the analysis. To keep water clean, you usually have to exchange it constantly. Pumping fresh water in, pumping dirty water out.
A huge amount of water.
A huge amount.
Yeah.
With a biofloc, you drastically cut that down because the bacteria are cleaning the water in situ.
So you're not draining local aquifers, and you're not dumping nitrate-loaded water back into the local river.
Exactly. And then you have to look at the feed factor.
Because they're snacking on the bioflocs all day.
Right. So the dependence on commercial feed just drops. And commercial feed is incredibly expensive and resource-intensive to produce.
That's the aha moment for the farmers, isn't it? It's not just about being green. It's an economic win.
Totally. You're buying less feed, you're pumping less water, and you're getting more fish out at the end of the day.
It aligns the economic incentive perfectly with the ecological one.
It really proves that sustainable aquaculture doesn't have to be some kind of, charity project. It's actually the smarter, more profitable way to farm.
So a dual threat solution. You tackle the hunger crisis with better, more reliable yields.
And you tackle the resource crisis by literally closing the loop. It just emphasizes that we don't always need new resources. Sometimes we just need to look at our waste in a different way.
Which I think leaves us with a pretty big question to chew on. If a simple fish tank can become a self-sustaining loop where waste actually equals food, why are so many of our massive industrial food systems still operating as these straight lines from resource to trash?
A very good question.
Thanks for listening to this deep dive, and we'll see you next time.